To find a minimum spanning tree for this weighted graph, I'll use Prim's algorithm. We start at any vertex of the graph, and I'll choose A. Consider the edges that are incident with A, these are shown in green on the graph, and choose one of least weight. In my case, that's this edge of weight 25. That will be the first edge in the tree. So I color that blue, and from now on the tree that I'm forming at each stage of the algorithm will be in blue, and the choices of edges to add into the tree at that step will be shown in green. An edge is under consideration if it has one vertex in the blue tree and one vertex outside of the blue tree at that step in the algorithm. In this algorithm, the sorting is done on a subset of edges, just those under consideration at each step. But this subset changes at each step depending on what the tree looks like. So here in green I'm showing the edges under consideration, and I will choose the one of least weight, that's the 30, and include it into the tree. Once that is included in the tree, it gives me a new subset of edges under consideration, those with one vertex in the tree and one vertex outside of the tree. Notice here the 70, which at my last step was under consideration, is no longer under consideration because it has both vertices in the blue tree. The edge of least weight from this subset is going to be the 50, and I'll take that and add it to the tree. At this step, I have the green edges under consideration. The one of least weight is here, the 40. So I add that to the tree. The new edges under consideration in green, and the one of least weight is right here, 55. The new edges in green, and the least weight down there, the 70. The edge of weight 38 here under consideration, and that is one I'm going to add to the tree. At this point, the 20 is the smallest weight, so I'll use that. And 32 comes next. One more edge to go, that'll be the 35. And I have every vertex included in the blue tree. The total weight of this tree is 395. I get that by adding up all the weights of the blue edges. And this algorithm guarantees that I have got the smallest possible weight for a spanning tree. So any other spanning tree that I might find on this graph will have a weight greater than or equal to 395.